Thank you for the kind introduction and having me at this event today. Good morning, good afternoon, and once again, my name is Nicholas. The main topic for today's summit is on modern data center for the edge, and I would like to discuss on high-speed migration strategies for the edge because this is a very important roadmap to ensure that the edge has a continual back-end solution with focus on providing high traffic connectivity and monitoring to meet service level assurance. It shall be crucial for mission-critical applications as well as end-to-end communication systems, linking internal stakeholders and business ecosystems. So, what is the edge, right? In defining the edge, there are two perspectives. The first definition is that of the customer's edge, located on the customer's premise, to support ultra-low latency applications. An example would be a manufacturing that requires a network to support fully automated robotics. The second definition is that of the network edge, located towards the network core. As networks ramp up support for 5G, cloud, and the Internet of Things, computing that has been focused on centralized data centers is now adding an edge-first distributed computing paradigm. This is to meet the demand for better customers' experiences and faster responses, something that is endlessly increasing. A growing number of distributed applications and microservices are being deployed in edge locations to service huge volumes of data that are generated at the edge. Local computing that offers higher bandwidth, lower latency, and availability of the network's edge is growing with this rising tide. As more activity is pushed to the edge, the entire network ecosystems have to adapt. Whether the setting is at the network edge or at the customer's edge, the demand for high-speed networking services and higher bandwidth increases tremendously. Its transformation. The edge is literally an extension of the cloud infrastructure, and this is also where connection occurs. You've got to know that connectivity plays a critical role at the edge, and the connectivity can be in different forms such as wireless, fiber optic, or copper medium. Most edge connectivity are located in the multi-tenant data centers, and for good reasons. MTDCs, in short as they are called, are typically built in close geographical proximity to areas of dense population. That enables MTDCs to take advantage of their location at the edge of the network in the drive of technological requirement for a lot of companies. But location alone is not enough without a backend solution that focusing on providing high traffic connectivity and monitoring to meet service level assurance. The typical networking for cloud computing and performance within the customer cage is based around a leaf-spine architecture. Here, the MTDC will rely on a highly agile and redundant physical layer infrastructure to meet the fiber density and low latency demands of customers. The structured cabling for the leaf and spine network fabric is supported by MPO or LC connector-based technology for 100 gig bandwidth or more. These configurations can provide massive processing power and is easily reconfigured to accommodate the expanding and fluid nature of an edge-based environment. It is imperative for today's network design to support massive amounts of traffic and crucially enables servers, storage, and network capacity to be scaled up independently. As data center trends continue to predict 25 to 35% annual growth, all right, traffic, data center speed is now everything. This means data center professionals are facing the challenge of future-proofing to be able to provide the best, most flexible course of action in the face of growing capacity demands and with as little disruption as possible. MTDCs that are flexible and ready to accommodate a variety of customer configurations will be primed for success. There are many data center networking applications available today, and certainly in the future as well. Some of the applications are specified by standard bodies such as IEEE, while some are covered by multi-source agreement technical specifications, or even proprietary like Cisco BiDi technology. Technical information from these applications are often insufficient for the design of a complex data center structured cabling systems. As such, many of the end users or designers would require expert guidance to support their applications and requirements. CommScope offers a suite of tools that simplify the task of design, deployment, and certifications of fiber connectivity in support of high-speed migration. Some of these tools would include the SystemX performance specifications, as well as the SystemX fiber performance calculator. Now, using these tools, CommScope Application Assurance combines these new technologies into an engineered guaranteed link design. Designed with speed in mind, you can be assured that as you progress to higher network capacity, your original infrastructure investment will support your needs and minimize your costs. Ultimately, when designing the infrastructure for a data center, we need assurance, right, that the infrastructure will support the intended applications as future applications within a given planning horizon to ensure a smooth migrations to faster speed. The process starts at the design stage by identifying the data center layout, including location of compute and storage equipment, spine and leaf switches, channel architecture, rack layouts, components, and cabling distances. Ideally, the next step includes infrastructure modeling. Using modeling tools that can predict the end-to-end channel link loss budget based on channel length and the components selected. Finally, the results from the calculations can be used to validate the applications supported or to iterate the process and change the architecture and components selected if required. When the installation is completed, the links and the channels can now be validated quickly with a field testers prior to finally project registrations for CommScope Applications Assurance Warranty. High-speed migration strategies are of great importance as it enables the network to continually expand and migrate to higher speeds easily. There are various high-speed optical networking technologies available today and in the future, right? Based on duplex or parallel optics. To leverage on these choices, the connectivity within the data center must be flexible, not only within the initial setup, but on day two as well. As an illustration, when using high fiber count trunk cables, the backbone cabling between the leaf and the spine switches can remain fixed. You can do this with a single 24 fiber MPO trunk cables, or two 12 fiber MPO trunk cables, or even three 8 fiber MPO trunk cables. Now, depending on the technology deployed, you may simply change the modules and the optical fiber presentations entering or exceeding the spine or the leaf cabinet. This eliminates the need to rip and replace the trunk cabling as you change from duplex to parallel optics and back again during an upgrade. While there are good use cases for both the MPO8 and MPO12 trunk cabling, the 24 fiber trunk cabling solutions, as well as the modules, offer the lower cost duplex support for multi-mode applications and the highest panel density. Now, let us review the various configurations that technology supports during a simple migrations. To maintain a duplex connectivity from the spine to the leaf switch, the 24-fiber technology allows you to aggregate the 12 LC connections over one simple trunk cable. 3, 40, or 100 gigabits per second channels can be aggregated onto a single 24-fiber trunk using a fan-out cable assembly or conversion modules. This simplifies the architecture by reducing the overall number of trunk cables used in the fabric and eliminates the need to buy, stock, prep, and install multiple cables. It also reduces the load in the cable raceways. 400G based SR8 is the first IEEE Ethernet fiber interface to use 8 pairs or 16 fibers. The MPO24 solution is well positioned to support these applications. In comparison, 400G based SR4.2 is the first instance of an IEEE.3 solution that employs both 4 pairs of fibers and dual wavelengths. MPO24 to MPO8 solution will serve this purpose, and with OM5, it provides a longer distance supports advantage over OM3 or OM4 optical fibers. Now, to future-proof data centers and accommodate technology transformation, designers must build the correct foundations for the network infrastructure connectivity, right? The tools are there. Newer, faster optics, lower latency, architectures, and rapidly advancing standards. But you need a unified strategy to keep your infrastructure agile and flexible. Fiber dense, yet easy to manage. Highly efficient and cloud-friendly. CommScope high-speed migration platforms combine modular fiber and connectivity components, network infra design tools, and automated infrastructure management. Together, they provide a long-term strategy that supports your continuing migration to higher speeds. Our proven solutions like pre-terminated fiber cables and modules provide the building blocks that enable you to support virtually any applications and scale on demand without disruption. This includes OM5 wideband multimode fiber that quadruples existing multimode fiber capacity and ultra-low loss components that can support the multiple high-speed connections and longer link distances with future applications that will demand. With ultra-high density fiber panels, you can also continue adding density incrementally as and when needed and reduce your upfront costs. The complexity of the infrastructure increases as more and more devices and connections are added. Complexity makes managing the cabling infrastructure more challenging. Complexity can also add to the risk of outages that may take time to troubleshoot. And remember, downtime can be very costly. Documentation is needed for accurate tracking of connectivity, capacity, audit of changes, and compliance. Manual entry is prone to errors and lacks in time. Now, risk mitigation is a strategy to enhance service level agreement by taking steps to reduce the negative effects of threats and disasters on business continuity. Automated data entries and updates will eliminate these deficiencies and improve the quality of service. AIM is one of the tools that helps with risk mitigations by reducing mean time to recovery from connectivity-related downtime. So what is AIM? AIM stands for Automated Infrastructure Management. The AIM solution is an integrated software and hardware platform that manages the entire physical infrastructure layer. At CommScope, we call our AIM solutions InVision. Using InVision, Automated Infrastructure Management, you can monitor and manage the entire connected environment in real time for greater control efficiency, and productivity. InVision fully documents the cabling infrastructure, including connected equipment, to provide a complete view of where devices are located and how they are connected. InVision automatically tracks connectivity changes and updates its documentation database in real time. It also creates an electronic audit trail of circuit configurations, history of how devices are discovered, and user activities. So when it comes to a full-featured, easy-to-use automated infrastructure management systems or solutions, CommScope InVision is the current gold standard. InVision provides actionable insights and visibility into the network's complex, interdependent physical layer, as well as the many devices that are connected to it. Modular, intelligent, and continually evolving, CommScope high-speed migration platform gives you a long-term strategy for providing high-traffic connectivity and monitoring to meet service level assurance. With the CommScope high-speed migration platform, you can be assured that you are in total control, backed by confidence and comprehensive capabilities that only CommScope can provide. That comes to the conclusion of my presentations. Thank you for your time and attention.